All right, section 3.1 is all about quadratics. So first, the standard form of a quadratic, which is what we are most used to, is ax squared plus bx plus c. We just call the coefficients of each of these terms a, b, and c. Obviously, the parent function is just y equals x squared, and this is what y equals x squared looks like. Right? We've talked about that already. So the first thing that we want to mention is that if our a term is positive, if it's greater than 0, the graph is going to open up. If it's negative, the graph is going to open down. And we talked about that idea already when we did transformations. Okay, if we had that negative outside like that, that was a reflection across the x-axis. So that's the same idea here. Right? So let's take a look at sketching this graph out using transformations. Okay, so there's three things that are happening here. The first, this tells me I'm going to go right 5. Then this negative out here is a reflection across the x. And finally, this plus 1 tells me I'm going to go up 1. So if I think about taking x squared, going right 5, I would end up over here. Then reflect across the x-axis, I'm going to end up something like this, and then go up 1. I'm going to end up with a parabola that looks something like this. Okay, so the vertex is this point right here. In this case, that vertex is the point 5, 1. And when we're talking about a parabola, the vertex is always going to be either a maximum or a minimum value. If the parabola opens down, that point is going to be a maximum. If the parabola opens up, that point would be a minimum. Okay, so let's take a look at graphing using a different method. Okay, let's say that we have a parabola in standard form. So another method we could use would be to factor and find the intercepts. So if I x factor this, I'm looking for two numbers that multiply to -5 that add to +4. So I think -1 and +5 would fit that. So this would factor into x minus 1 and x plus 5. Right? So if I set each of those equal to 0, I see that the intercepts are going to be +1 and -5. All right? So +1 and -5 are where this parabola is going to cross the x-axis. Now, we also want to find the vertex using this information. The key here is that the x-coordinate of the vertex is always halfway in between the intercepts. Okay? The x-coordinate of the vertex is always halfway in between the intercepts. So halfway in between these intercepts would be the point -2. So I'm just going to take -2 now and plug that into my function. So -2 squared plus 4 times -2 minus 5. So that'll be 4 minus 8 minus 5 would get me 9. So the vertex is the point, -9, is the point -2, -9. Yeah, there we go. So my parabola is going to do something like this. right? So we found the vertex was the point -2 and -9. And in this case, that is a minimum value. That's the smallest value that this parabola would reach. All right? So the vertex form of a parabola looks like this, like our first example there. F of x equals a times x minus h squared plus k, where the vertex is the point hk. Now notice that we have a subtraction sign in here. That means whenever I'm writing down the coordinates of the vertex, I need to take the opposite of whatever this value is. Now, vertex form is just helpful when we're graphing, right? It's easy to find the vertex and go from there. So let's just real quickly name the vertex of each of these parabolas and tell whether it opens up or down. So if I'm looking at this form, x minus h squared plus k, the vertex in this case is going to be the point -1, -5. And we can also think about that in terms of our shifts, right? If I have a +1 on the inside, that means I'm going to the left 1, right? So the vertex would be -1, -5. And this parabola is going to open up because my a value is positive, right? For b here, my vertex is going to be the point 5, and now there's no k value. Well, if there's nothing out here, that would be like adding 0, right? So this would be the point 5, 0. This parabola is going to open down because my a value is negative. In our last one here, I don't see an h value. Well, I can write this as -3 times x minus 0 squared plus 2. Right? If I don't see an h value, okay, again, that would just be 0. So the vertex here would be the point 0, 2. And this is going to open down because my a value is negative. So here, let's kind of go backwards now and write the equation given some information. So here, we're given that the vertex is -3, 4, and then we're just given a point. So if I'm given the vertex, I'm going to use my vertex form. So f of x equals a times x minus h squared plus k. So I know the vertex, so I'm going to plug that in for h and k. So this is going to become f of x equals a times x minus -3. So a double negative we can just write as +3. Then my k value would be 4. But now I still need to figure out what my a would be. To do that, I'm going to use this point that they gave me. I'm going to plug -4 in for x and 7 in for y. Right? F of x is just the same as y. So I'm going to say 7 equals a times -4 plus 3 squared plus 4. I just plugged -4 in for x and 7 in for y. And now I can just solve this for a. So I'm going to have -4 plus 3 is -1. -1 squared is +1. So this is just going to be 1a plus 4. Subtract the 4 over, and we get that a is equal to 3. So my answer for the equation is going to be f of x equals 3 times x plus 3 squared plus 4. So now to graph, we know the vertex is at -3, +4. I know the point -4, +7 is on the graph. All right. So if this is my vertex, one thing that we haven't mentioned yet, but parabolas are symmetric. Okay, so across a vertical line that would go through the vertex. So if the point -4, 7 is on the graph, I went one left of the vertex. If I go one to the right of the vertex, that is going to be the same y-coordinate. Right? So if I know negative 4, 7 is on the graph, negative 2, 7 would also be on the graph in this case. Right? So let's now take a look at converting from standard form to vertex form. All right, so what we're going to use to do that is completing the square. To complete the square, what we want to do is kind of think about this as 0 equals x squared plus 6x, not plus 10, minus 10. All right, so then I'm going to add this 10 over to the other side to get rid of it real quick. But I know that I'm going to add something to both sides of the equation. So I'm going to just automatically put a little blank in there. So I'm going to have x squared plus 6x plus some blank. And we looked at completing the square when we talked about circles way earlier in the year. So this is just the same thing. To complete the square, oops, I forgot my x, I want to take half of my b value. So in this case, my b value is 6, and square it. Right? So you can make a note that this is half of b squared. So half of 6 is 3, 3 squared is 9. I'm going to add 9 to both sides of the equation here. So the reason that I do that is this becomes a perfect square. This will factor into x plus 3 times x plus 3, or x plus 3 squared. We could x factor this and see that, but the shortcut, okay, if you remember, we talked about completing the square before, this value right here is just b over 2. Right? So now, finally, if I subtract the 19 back over, I'm going to get x plus 3 squared minus 19. So this is the vertex form of this parabola. Now we can easily see that the vertex is the point negative 3, negative 19. Okay, so we're just completing the square to find the vertex. All right, so now let's take a look at one other example here. In this one, our leading coefficient is not 1. All right, but what we want to do is still subtract that 8 over. So we'll have negative 8 plus something equals 5x squared minus 20x. Now, whenever we have something where our a is not 1, I need to factor that out. So what I'm going to do is make this 5 times x squared minus, if I factor a 5 out of here, that'll just be 4x, then plus my blank. We need this coefficient to be 1 in order to complete the square. So now, if I take half of my b value, that would be negative 2. Negative 2 squared would be positive 4. So now I want to add that same value to this side, but I'm not adding 4. I'm adding 5 times 4. So over on this side, I would add 20. Okay, we've got to be careful of something like that. If our leading coefficient is not 1, we need to make sure that we're adding the correct value to this side. In this case, that would be 20. So now we have 12 equals 5 times, if I factor this now. This will be x minus 2 squared. And finally subtract the 12 over. And we get that our function is 5 times x minus 2 squared minus 12. So now we can see that the vertex is the point 2, negative 12. All right. The next couple of examples, we are drawing the graph given an equation in vertex form, and we want to find the vertex and at least 2 other points. So right off the bat, I see that the vertex is the point negative 1, 6. So negative 1, 2, 3, 4, 5, 6 is right here. I know that my parabola is going to open down, right? Now, for this one, it says find 2 other points. The easiest way to do that is to just go 1 to the right or to the left of the vertex and plug that x value into the function. So here, if I go 1 to the right, that x value would be 0. So I'm going to plug in 0. I'm just going to evaluate. F of 0 is going to be negative 3 times 0 plus 1 squared plus 6. So that'll be negative 3 times 1, right? 1 squared is just 1 plus 6. So negative 3 plus 6 is going to get me 3. So the point 0, 3 is on the graph. Now, we mentioned this in a previous example that that a parabola is symmetric, right? If I were to draw a vertical line through my vertex, that would create symmetry. That means that if I go 1 to the left of my vertex, those 2 points are going to have the same y value, right? So once we find 1 other point, we automatically know a second point here, right? So now I can finish sketching my graph. We have a real skinny parabola here. Okay, so why don't you guys take a second and try the next one? There's not going to be a question pop up on the screen, but I want you to pause the video for a second and try the next one. All right, so here is what this one should look like. Okay, again, we're thinking about our f of x equals a times x minus h squared plus k. That means the vertex is the point 1, negative 1. And then I plugged in 0 and got out a y value of 1. I went 1 to the left of the vertex. And we said, well, if that's true, we don't even have to plug in the second one. But I wrote down the work just to show that that y value over here of 2, if x is 2, that y value is the same. Okay, so this is what our parabola would look like. All right. Now, let's take a look at graphing something in standard form by finding the vertex. All right, so up here, just a couple of things that we could try. All right, if our equation is in standard form, we can factor, like we did in a previous example. We can complete the square to find the vertex, or there is this other little trick. This formula here, x equals the opposite of b over 2a, will always get me the x coordinate of the vertex. Okay, so here my a value would be 1, right? My b value is negative 2, c is 3. So the x coordinate of the vertex is going to be the opposite of negative 2 over 2 times a, which is 1. So that'll be 2 over 2. The x coordinate is 1. So if I plug in 1 now, I'm going to get 1 squared minus 2 times 1 plus 4. So 1 minus 2 is negative 1 plus 4 is 3. So the vertex is the point 1, 3. All right. Then it says find at least 2 other points. So let's go 1 to the left and plug in 0. So f of 0 is going to be 0 squared minus 2 times 0 plus 4, which would just be 0 minus 0 plus 4. So the point 0, 4 is on the graph. And again, these are symmetric, so that means the point 2, 4 is on the graph. So here is what my parabola is going to look like. Okay, so we can use x equals the opposite of b over 2a to find the vertex. So again, I want you guys to pause the video and take a second and try the next example. All right, so here's what this one would look like. And if we use this x equals the opposite of b over 2a, I get that the x coordinate of the vertex is negative 2. If I plug negative 2 in, I get negative 3 for the y coordinate. Then we want to just take a point either to the right or to the left, it doesn't matter. I chose negative 1 first, so a point to the right of the vertex, and I got negative 4. Well, then we automatically know that the point negative 4 is also on the graph, but I went ahead and plugged it in just to show that. All right. Last couple of examples here. We want to, without a picture of the graph, determine whether this function has a maximum or a minimum and find that value. So this is a parabola with a positive a value. Right? The a value would be positive 1. That means this parabola opens up. That means that the vertex is going to be a minimum value. I know that without seeing a picture at all. The minimum value is going to be the vertex. We have a couple of ways that we can do that. We could complete the square and put this in vertex form, or we could use what we just talked about, the x equals the opposite of b over 2a. So the opposite of b would be positive 4 over 2 times 1. So 4 over 2 gets me the x coordinate of the vertex is 2. So if I plug 2 in, 2 squared minus 4 times 2 plus 3. So that'll be 4 minus 8 is negative 4 plus 3 is negative 1. So the point 2, negative 1 is the vertex, and that is a minimum. Now, this also says find the range of the function. Range, remember, is all of the y values that the graph reaches. Okay, so here, if I know that the point 2, negative 1 is the vertex and it's a minimum, that means that a real quick sketch of my parabola would look something like this, right? Where we know that that y value is a negative 1. So the range, okay, if we have a minimum, is going to be negative 1 up to infinity. Right? The graph is continuing on forever up. So the range here would be, and I am including negative 1. There's no break in the graph or anything here. Negative 1 to infinity would be my range. If my parabola opened down and I had a maximum, I would have a range of negative infinity up to the y value of that vertex. Okay. Final example. It says a revenue function is given by 15 plus 114x minus 3x squared. We want to find the value of x, for which the revenue is a maximum. Well, I know that this parabola is going to open down because I have a negative a value. Even though this is in the wrong order, the a value is the coefficient on the x squared term. So here, my a is negative 3. That tells me the parabola is going to open down, which means the vertex is a maximum. So let's find the x coordinate of the vertex, negative b over 2a. So b would be 114, so negative 114 over 2 times negative 3. So that'll be 114 over 6, which is 19. Okay, so we found the value of x for which the revenue is a maximum. Now, to find the maximum revenue, I'm just going to plug 19 into my function. So 15 plus 114 times 19 minus 3 times 19. So what does that get us? 19 should get me 2,124. So that is the maximum revenue. We don't really know the situation here, but x equals 19 and $2,124 would be the maximum revenue. Okay, so that is it for this video. The final question is going to pop up asking you what questions you still have.